My name is Kristen Schlick, and this is my engineering exploration. What interesting discoveries did you make investigating ramps as an adult learner? I must confess that this experiment took a lot longer than I expected, and as I look back on my experience, I really put the 5-step engineering process to work. As I began to survey where I wanted to construct my ramp structure, I used the longest ramp first. I knew I wanted to use that one first to get a good long run, but not too steep. I had to ask where would be a good place to start, while simultaneously imagining what the structure would look like. Once I found the starting place for the ramp, I needed to plan the height, distance, and drop of the next ramp. I looked around the room for items that were stable, somewhat flat, and around the right height. As I was creating the structure, I ran into a few areas that needed to be improved, which began the 5-step engineering process all over again. I probably went through the process a good 4 times during the construction and execution phases until I had it the way I thought it should be. Thinking of spatial relationships, what specifically did you notice in terms of spatial relations language? The vocabulary was very specific. There were many position and location words used, like, the top of the ramp that is connected to the water bottle needs to be more secure. There were many transformation words being used to describe what the ball was doing when it went off the ramp in areas where it shouldn't have. There were descriptive words describing the distance the items went beyond the ramp. You made it to the table this time. There were vocabulary words to explain the movement intended as the track was being assembled. We want the ball to travel down towards the bottle and then turn around toward the TV. How would you introduce or promote a ramp building exploration with young children? I would begin with a book to introduce the concept, and then I would use the strategy think, show, talk, tell to cement the idea of what a ramp does. Then allow plenty of time for the children to experiment and explore. What are some considerations and constraints? There needs to be enough material for children to explore on their own if they would like. There needs to be enough room to spread out. Ramps take a lot more space than you think. There needs to be enough time for the children to really get into it and explore. If possible, the children should be able to keep their ramps up to continue later in the day or into the next day. That way, the children can continue to build on the skills that they are working on and work towards their goals. What are the opportunities for supporting other developmental domains such as language and literacy, visual and performing arts, social and emotional development? I found a couple of really good books that use great illustrations and photographs to show the benefits of ramps in our everyday life. The natural vocabulary used when building ramps is very beneficial, loaded with descriptive, directional, and precise words, which is great for language and literacy. The development of visual discrimination is heightened when one needs to observe and examine why the ball did not travel down the ramp as one planned. This activity also helps with social and emotional development because it takes a team working together to build a ramp. Everyone is able to contribute their ideas as they shared materials. And when the structure is complete, the players must take turns using the new machinery. What are some extension ideas you have about this activity? How would you expand it both within the domains of science and math and into other domains? You could purchase wooden cars and let the children decorate their vehicle for use on the ramp. Provide a trash to treasure supply of random materials and let the children create. Take photographs from beginning to end as the children are working. Print out the photographs and use them either as individual books that the children can dictate what they're doing in the photographs, or use the photographs to create a combined class book that you would keep in the library. Use a stopwatch to record the amount of time it takes for the item to complete the ramp. Use a tape measure or measuring tape to record the length the items reach beyond the ramp. Videotape the children using the ramp structure and show it to them later. Include dramatic play items in the construction zone, such as hats, gloves, screwdrivers, and hammers. Maybe even some caution tape. Create songs and chants about ramps. Okay, I just came up with this one off the top of my head. A ramp is a simple machine, simple machine, simple machine. A ramp is a simple machine with no moving parts. It helps move objects high and low, high and low, high and low. It helps move objects high and low to keep us on the go. How about bring a wheelchair into the center and let the children practice moving themselves up and down a shallow ramp to understand its function. I'm sure if they ran up against a block versus a ramp, they would really understand how a ramp helps move objects up and down. And here are my references. So thank you so much for viewing my exploration into engineering. I had a great time, and I hope you can see from the pictures just how much fun I had. Thank you.